Hello everyone, welcome back to the channel, and in this video I would be continuing with the series of implementing the road network design project in C++ using the Kruskal's algorithm, which comes under the greedy approach. So in the last video we implemented the basic Kruskal's algorithm in our code editor, and in this video I would be implementing the file handling part as well as the GraphViz part of the project, in which I would be transferring the output of the terminal to a configuration file with the extension of .gv, and then we would be rendering out our graph in a nice manner to show both the original graph as well as the MST, the minimum spanning tree, in a very beautiful way. So let's get started. Another thing that we would be covering here today is that there were some errors in the previous program which I got to know about later. So I would be correcting those errors right now. So let's get started. Firstly, let me show you what the errors are. So I am compiling this program, and let me take two and two. So in the graph, I have the edge 1, 2 with the label 3. Now the first error is that there is no square bracket here. There should be a square bracket here. So I would correct that. And this is the second error. It terminates automatically. I don't want this. If we see the code I made previously as well, I am expecting my MST to give me my minimum cost as well as the edges in the MST, the minimum spanning tree. But here, as I see, there is no such output. So I am correcting that. I think there is a simple fix for that, not a big issue. So firstly, let's put the square bracket over here. Okay, awesome. And the other problem was that the output was not showing. So I think I made an error in initializing the parent vector. So I should be giving it an initial size, which I think 50 should be good enough. 50, 20,000. I think 50 is good, more than good enough. And so I think this should solve our problem. Let's see. It's compiling right now. 2, 2, 1, 2, 3, 4, 5, 6. Yeah, so I am getting the output now. Great. Now let's start with another thing I would like to point here is that the nodes here are integers. I don't want them to be integers. I want them to be the names of the cities. So let's do that. So firstly, let me introduce a map over here. So I would introduce a map over here with the parameters of string and int, and let me name it node map. Great. Now after this, what I can do is uh, where am I, what am I printing as output? I am printing as output my MST. So here I should make the changes here. And is there any change to be made here? Let's see. Okay, so firstly, what I can do here is I can define a string node 1, comma node 2, and what else can I do? I can have something like, to connect this, I have find auto node in my node map. So I am basically applying the for each loop here. Find, it should be 4. Why am I writing find? Maybe because of this. Never mind. 4 auto node in node map if my node dot second is double equal to end 1. That is, when I take input in my hash map here, if my node dot second is double equal to end 1, what I'm going to do here is I'm going to put node 1 is equal to my node dot first, and if my node dot second is double equal to end 2, I can have my node 2 equal to node dot first. Okay, great. Now I think this is good enough. Let me see. I can also add the preprocessor directive for my file handling. So something like this. Let's stream. And now what I can do is this. So yeah, I want this to be printed. Okay, I want this to be printed. Sure. Now I want to basically forward the output of the terminal to my .gv file. So how can I do that? Let me first uh, use the offstream class that stands for output fstream, and let me define it as output file. And what I can do here is, as I am printing the MST over here, I would be storing the configuration content of the configuration file in the output.gv file. Okay, great. So now I have my output.gv file. Now what I can do here is that first print, I have to transfer data in such a way that it matches the format. So let me create a output regarding its format. So I am creating a graph which is named MST, and there is an end of line over here, because as we saw in the previous lecture, in the previous video, in the documentation there was a space and then we were listing out the edges. Okay, now what we can do here is, what can I do? I want this to be printed. That is not a problem. What can I do here? Now what I want basically is that I want to give my my configuration file the set of nodes along with the edges and the weights. So I have the edges over here, I have the nodes over here, I have to give the weight in my MST. I don't think I have given the weight. Let me see. Where is my MST? Where have I defined it? I would have defined it in the Kruskal's algorithm. Yeah, I would have defined it in the Kruskal's algorithm. Yeah, yeah. It's integer integer. I haven't added the weight. So what can I do here now? What I can do here is my nodes are strings, so I can take in string over here, and then I can also take in the weight. So another pair. So something. Let me define it as weight. Something like this, I presume. Let me see. Okay. Now I have this. I have changed the MST over here. So what can I do over here? I can change this. So I have my string and weight. So I can do something like uh, this would be my node 1, my node 2, and my weight. Okay. Now in the MST, I want to print this, and I have I have put this as well. So, yeah. So I have put this. Now I have to list the edges. So my edge in MST, yeah, there should be some change here as well. First dot first edge, first dot second dot first, and what do we have here? Now I have to put the weight as well, as I know. So I would be using the label attribute label equal to my edge dot second, which is my weight. Okay, my string I didn't close it. So something like this. I have this, I have the first edge, I have the hyphens, I have this, I have the label equal to my weight. Then after that, this code should be closing. How did I do this here? Something like this. Okay, I know that it would be ending with a new line. So label equal to this. I think this is correct. And now for the out file, I have my h dot first, the same thing, dot first, and then my hyphens, something like this. Then I have my like the above, h dot second dot first, h dot first second dot first. My edge is MST and MST is string weight. So this is node 1. This should be first dot second. This should be first dot second. Okay. Then after this, I'll add the label attribute label equal to then my edge dot second, that is my weight, and after that I would be ending this. So something like this. Okay, great. Now I also have to end this. So file out file. I am ending this. Great. And now I will be closing my output file. So this is what I am going to do. Next, I see we can, this is a little not clear. So what I am going to do here is firstly something like cout, please enter number of nodes present in the graph. Okay, now I am going to get this inputted a column over here and say C input number of nodes. I am entering the number of nodes. Now please enter, let me start this from a new line. Please enter number of edges present in the graph. Okay, now I would just quickly get this inputted. Great. Now I have to do the same thing as I did above for my original graph. So instead of printing this here, what I can do is I can use my offstream class with original output file, something like this. Original out file, and let the file name be original.gv. Great. Now what I'm going to do is original out file and then the same thing as I was printing according to the format. So the name of the graph is original and I am ending this line. Now, okay, the node changes would be made here as well. So firstly what I can do here is I don't have to input this. Okay, and I can get my N1, N2 and my weight. My weight, have I declared weight? Let me see. So I have to declare weight over here. Let me just declare it and see what happens. Weight, and then I would be entering. Okay, I have to declare my N1 and N2 as well. So it will be declared like this because I am taking string as input. Now, now what I can do here is I have this. What can I do? I have inputted this and the weight I have declared. Okay, weight is also being inputted. So I have my weight over here, I have my node over here. Now I have to push this into my edges. So let's see. I can I have something in mind. Okay. So what if I node underscore map dot find N1 double equal to node underscore map dot end, and then my node underscore map N1 is equal to my node. I don't need these curly braces as well. Let me just remove these. I don't need these. Node map N1 is equal to node map N1 node underscore map dot size plus 1, something like this. And now I can do another if my node underscore map or find N2 is double equal to node underscore map and dot end, then my node underscore map N2 is equal to node underscore map dot size plus 1. I think this should work. I'll compile this all together in one go so that I can work out the issues together as well. Okay, so now I have to push in the edges vector. So edges dot push underscore back. And how did I declare my edges vector? Where did I declare it? Where is my edges vector? Oh, over here. Three integers and two pairs. Okay. So yeah, here. So what I can do here is that I can take my weight, comma, uh, node underscore map and comma, comma, node underscore map and two node map one and two, and I would have to have this also in curly brackets, something like this. Great. And now what I can do here is I have pushed the nodes to my edges. Now I have to, did I? Yeah, I have this format as well. So I have to add the edges now in my .gv file, my original .gv file. So original out file and one, so this, and after that I can have my end two, and then I can have my label format. So it would be something like this, label equal to weight, and then uh, something like this is a string and a new line and a semicolon. Okay. So I think this is good enough. Let me see. Now what can I do? Okay, so now I have, no wait, I missed something. I should also add, I should also add a ending in my ending format. So something like this, original out file, and then it is going to end with something like this. So it's going to end like this, and then I have to close this. So original close, and this is closed. Okay, so this has been done. Now I think this is good enough. Is this running? Weight is not declared in this code. Weight is not declared. Okay, this should be int. No matching function call for std vector. This. Okay, I have to change the Kruskal's algorithm as well. Okay, let me see. What can I do? Can I do edit changes? What is happening? This is a pair. This is a pair. Something like this. Okay. So let's say three edges are three. I have to put a column over here. Okay. A B two B C one C A one. So my minimum cost is 2, that is this 1 and 1, and these are my values. Okay, great. And am I getting my output file? Let me open my PowerShell. PowerShell. What happened? Yeah, this is my PowerShell, and I'll just go into the directory cd road underscore network underscore design, and now okay, now I have my original.gv and my output.gv. So it is working. It is working. I also created a readme file over here in the first video. So do check out the first video as well. And okay, so let's continue. Okay, now I would have to compile this GV file as well. So let's compile this GV. How can I compile this GV? As far as I remember, we use a command known as system. So what I would be doing here is that I would be using the system command in C++ to basically render or compile whatever we want to say my .gv file into a what is this happening? Okay, one more thing I would like to change, a quick change. Yeah, this. I don't need curly brackets over here, so I'm removing this. If I don't need this stuff, so I don't think I should have it. Done. Yeah, let's continue. Yeah, so how did we compile this? Dot tpng, then the name of my .gv file. So original.gv. First, I am rendering my original file with the output file in the form of png, original.png. Okay, so this is good. And system dot tpng by mst. So output.gv in the form of my output file is in the form of output.png, And now I have compiled this. Now let's see what is happening. Let's see. Enter the nodes 3. I have to add a colon over here. So let me add a colon. Where is it? Yeah, yeah. Let's run this again. 3, 3. Let A, B, and 2, B, C, and 1, C, A, and 1. Okay, this is working. Now let me go back to my PowerShell. Okay, and I'll go to my desktop. I'll go to my root network design, and okay, I have my original.png. Now the command to open this file, as far as I remember, is PowerShell -c, and then in the current file I want to open my original.png. So is this working? This is working. Great. And let me see my output file as well. This is working. Great. Great. So our project seems to have been completed. I would like to automate this as well. How can I do this? Let's see. So I am using a command in the terminal. So I would be using the system function, invoking the system function in my C++ file. So let's do that. System for something like power shell C. I am using Windows over here, so that's why I am using PowerShell. If we were using Linux, then this would be xdg-open, and if we were using Mac, then we would be simply using the open command. So that's a small difference I would like to point out. I have put double slash over here because if I put only one slash, then it would get ignored by the compiler. So that's why I did it. Let's run this again, and hopefully this would also get automated. 3, 3, A, B, 1, B, C, 1, C, A, 2. This is working. So I think this is it. Uh, yeah, so I think this is about it, and this is the end of my road network design project, which is implemented in C++ using the Kruskal's algorithm, which comes under the greedy approach. So, if you like the video, please consider subscribing to the channel and connecting with me on socials. Until next time, Thank you very much. See you.